Alright guys, we're back for part 2. This time we're not going to be able to use graphs because our y variable is going to be squared. So you can't just solve for y and graph it. So here we go. We are going to go over the 2 ways to algebraically solve systems. First thing we're going to go over is substitution. Substitution is nice because all you have to do is solve for one of the variables. Notice that you do have to get that variable completely alone. So if you're solving for x, there can only be one x in the equation and the other side has to have only y on it. If you're solving for y, you have to have one side that only has y on it, the other side only has x on it. Okay? If you do not follow those instructions, you will get it wrong. Alright, so x equals this right here. Notice there's no x's in x equals. Okay? So we're going to take that and we're going to replace this x with those values. So we've got our 3. And then in place of this x, we're going to put 3y plus 3. And we're going to square it. And we're not going to kill a puppy because we're going to remember our rules. So 3y plus 3 squared plus 2y squared minus 54y equals 143. Alright, so from here, we're going to actually square the 3y plus 3. We're going to remember that this actually means 3y plus 3 times 3y plus 3. So you're getting 9y squared, 9y, 9y, and a 9. So we have 3 9y squareds. If we combine like terms, we get 18y plus 9. And then we're just going to write the rest of that equation without changing anything. So this 3 is from the original equation, and then just plus 2y squared minus 54y equals 143. Alright, so we're going to distribute our 3 through. We get 27y squared plus 54y plus 27 plus, and then we've got our 2y squared minus 54y equals 143. From here, we're going to combine like terms. So our 27y squared is going to combine with our 2y squared, giving us 29y squared. Then our 54y and our negative 54y are going to come together and be 0y. And then we have a plus 27 equals 143. Since we don't actually need to write 0y, we have 29y squared plus 27 equals 143. And because I just have y squared, I can solve this fairly easily by subtracting the 27. And I get 29y squared equals 116. And we're going to divide both sides by 29. And we're going to get y squared equals 4. Square root both sides. And we get 2 answers for y. So y is either going to equal 2 or negative 2. Now notice we're not done because we need an answer for both x and y. So we're going to come over here. I'm just going to steal this equation from up at the top, which is x equals 3y plus 3. We're going to use our 2 new y values. So we're going to start with y equals 2, which means our answer is going to be something comma 2. So x equals 3 times 2 plus 3 is 9. So one of our answers is going to be 9 comma 2. Let's make 9 look a little more 9-ish. Okay, and then we're also going to use y equals negative 2. So that would be x equals 3 times negative 2 plus 3, which is going to give me negative 3. So my other answer is going to be negative 3 comma negative 2. So that's how you do substitution. So you solve all the way for one variable, and then you have to go plug it back in and get the other variable. So now let's go over elimination. Elimination only works if you can completely eliminate one of your variables. So if you can completely eliminate all the x's or completely eliminate all the y's, this is a great method. So here, if you look, it's going to be super easy to get rid of all my x's, but not my y's. So I've got a y squared and a y, but on the second equation I only have a y. So I can't get rid of y's. But on the top equation, I have a single x, and the bottom equation, I have a single x. So I can easily get rid of x. Now, right now, if I add these two equations together, I'd get y squared plus 4x. That's not 0. So we're not going to add them, but if we look, we can easily subtract. So this would be y squared, and then 2x minus 2x is 0. So this goes to 0. And then 3y minus negative y is really plus y. So this is plus 4y equals, and then negative 2 minus negative 2 is 0. Now, this turns out super easy for factoring, because all you have to do is factor out the greatest common factor of y. So it'll be y times y plus 4 equals 0, which means either y is 0 or y plus 4 is 0, which means that y equals either 0 or negative 4. Okay, again, I have my y values, which means I know that my answer is going to be something comma 0 and something comma negative 4. So we got to go figure out what that is. So let's go ahead and split it. Pick one of your equations. I'm going to pick the linear one because it's going to be a little easier. That was 2x minus y equals negative 2. I'm going to plug in my y values. So we've got our y equals 0 and y equals negative 4. So I'm going to start with y equals 0. So y equals 0 would be 2x minus 0 equals negative 2, which would be 2x equals negative 2. Dividing both sides by 2, you get x equals negative 1. So we plugged in 0 for y, we got out negative 1, so our answer is going to be negative 1 comma 0. Now we have to do it again for y equals negative 4. So that would be 2x minus negative 4 equals negative 2. So this is really 2x plus 4 equals negative 2. So subtracting 4 from both sides, you get 2x equals negative 6. Dividing both sides by 2, you get x equals negative 3. So the 2 points where these equations would cross, if we actually graphed them, but we can't because there's a y squared, would be negative 1, 0 and negative 3, negative 4. So those are the two different methods. You have elimination, which you have to be able to completely eliminate one of your variables. Or you have substitution, where you have to be able to completely solve for a variable, or there's a variable already solved. For each of the following, I want you to find the solution using any method you want. So for these two equations, any method you want. For these two equations, any method you want, just so you are aware. This one is a special case, so pay attention when you're solving it. Okay? And then these two, use any method you want. Alright? Alright, wishing you guys the best of luck.